arrange it, and that's it. And how about we have a multiplication? So I think you can verify this by yourself. Right? You just randomly put constant numbers there, and you will still get this result. So yes, linear combinations is a linear transformation. Okay, then definition 2, matrix. A matrix is a rectangular array of numbers arranged in rows and columns. Okay, and usually we'll call it a m by n matrix, which means this matrix has m rows and n columns. Okay, so it looks like this. So you put a bracket on both sides, and you have a number inside. And this is m by n, meaning that it has m rows. This is called row, goes horizontally. Okay, so first row, second row, to m rows. Okay, and when you go vertical, it goes column. Okay, so first column, second column, to nth columns. And for the first elements on the first column and first row, we will denote it as A11. Okay, and for the for the elements here, which is on the first row and second column, we will denote it as A12, etc., etc. Okay. Right, and like when you start to, like when you take the econometrics course, you are going to deal with a lot of matrix operations, and so one of my suggestion is to put down the dimension of, or we call it dimension, the dimension of the matrix when you do the operation, because sometimes the notation is kind of confusing. Okay, and put it down like explicitly, that can help you like to avoid some like error. Okay, so to make sure that you get it right, which you will see, like, you will figure it out in the end, but this is my suggestions. Okay, okay, so matrix has the following operation. First, additions. We can actually add two matrix. Okay. Try. Okay. Let me put it down. So first, when you do the addition or subtractions for these two matrices, you have to make sure that they are in the same dimensions. So both matrix A and B are n by n matrices here. And when you add them up, you actually add each element on the same positions and put it in the same position after you add it up. Okay. So in the end, you will still get the n by n matrix here. Right, so that's how you operate the addition in matrix. And how about multiplication? Let's say that we have a constant number c here, and if we want to multiply it, then actually we multiply each element. Okay, here. And of course, you can do multiplications and addition at the same time. It doesn't change anything. Okay. Right. Then is the matrix multiplication. So here I show is the scalar multiplication, which you can take that as a real number, like 1, 2, 3, anything there. But what if we want to like multiply matrix by matrix? And that will be much more difficult here. Let me show you. Okay. Okay, so this is how you do the matrix multiplications. Says that we have two matrices. Now focus on the dimensions. So for the matrix A is n by n, and for the matrix B is n by p here. Okay, and these two matrices can do multiplication if and only if these two are at the same dimensions. I mean, if only if A has n columns and B has n row. Okay. If that is true, then you can do the multiplication in this way. And how does it look like when you do the multiplications, which is AB here? It is a matrix M by P here. Okay, and let's say that